All right, we're going to bring back our old buddy, the tangent line now. So we're going to find the tangent line at this point of this given function. F of x is equal to x squared plus 1 over x squared minus 4. All right. What is a tangent line again? Or how do I work with tangent? As soon as you see tangent, what are you thinking? Derivative, right? Because the slope of the tangent line is the derivative. That should be that Pavlovian response. Oh, tangent, bam, automatic derivative, right? And we can't simplify this rational expression anymore. So guess what we get to do? Quotient rule, baby. Yeah. Now we've learned the quotient rules. Let's rock the socks off of it. So the derivative of the top, because it's the first thing you see, you always take the first derivative of the first thing you see. Derivative of the top, which would be a 2x, times the bottom, minus the top, which is x squared plus 1, times the derivative of the bottom. Now I scooted this over because it was obvious that the derivative of the bottom is just going to be a nice sweet little 2x all over the bottom squared. All right, now clean it up. F prime of x is now equal to 2x cubed minus 8x. Oh, that's nice. Minus a 2x cubed minus 2x. Ooh, this isn't too shabby. This is a plus 2x cubed and a minus 2x cubed. Okay. Negative 10x over x squared minus 4 squared. So there's my generic slope, right? My derivative is my generic slope of the tangent line. I specifically want to know what's happening at the point 3, 2. So in order to find my actual slope I'm going to put this down here so that we can see it, and I'm going to scoot this up a little. So now I'm going to find my slope when x is 3. So negative 10 times 3 over 3 squared minus 4 squared. So negative 30 over 25. We can reduce that to have a nice little slope of a negative 6/5. Now you just do point slope form. Y minus 2 is equal to a negative 6/5 x minus 3. Do work. And then I'm going to add 2. When I add 2, I get that common denominator. So I've got a negative 6/5 x, and if that's out of 5, then I've got 10/5. So that's just 28/5. Do you get a calculator? No. Do we know how to find common denominators? The answer should be yes. If you're struggling with that a little bit, now's the time to get good at it, right? We'll be practicing these more and more and more, so now's a good time to get good at that. All right, let's do another one. We're not going to do a tangent line here. Let's just do some finding derivatives just in general. Example 4, find the derivative. Just lots of derivatives. Getting this process down, that's going to make your life easy. F of x is 9 over x to the 5th. Now, I don't want to do the quotient rule for this. I don't need to do the quotient rule for this. What can you do? Yes! Take this x to the 5th and bring it up top. Remember, anytime you move an exponent to the other side of the fraction bar, it changes the sign. So this is now 9x to the negative 5. Power that. Bring that in front, so it's negative 45x to the negative 6. Whammo jabammo. Nailed it. Right? Be efficient with this math. Anytime you have the quotient, be efficient with that. The only time in this section that we're not going to quote unquote be efficient is practicing the product rule. Believe me, there will be plenty of problems where you can't algebra first. So don't worry. We will get the product rule in reality, but I want you to know how to do it before we get there. Okay? So practice that so you make sure you know how to do it. So when the time arrives, because it will, you'll be ready. Okay, let's take the derivative of this one. F of t is equal to 3t to the 16 minus 4 over t to the 6. Monomial in the denominator. Algebra first. Split that bad boy right on up. Don't go through trying to get all crazy on that. Split that up. Do that algebra first. F of t, because I haven't taken any derivatives next yet. Make sure you're watching your notation. That's a big deal. 3t to the 10th minus 4t to the negative 6, right? I don't have any other t's to cancel out, so if I move it to the other side of the fraction bar, that gives me that negative exponent. Here, like bases, you subtract whenever you do division, so 16 minus 6 is 10, right? You good with my algebra? Now we take a derivative. Now we change our notation. Bring the 10 in front, giving me a 30. Subtracting 1 is t to the 9th. Bring the negative 6 in front, will be a positive 24, right? Negative times a negative. Subtracting 1 is t to the negative 7. All right? You've got this. You've got this, you've got this, you've got this. All right.